This is R.D. Sharma's solution, class 12, chapter 3, binary operations. Exercise is 3.4. Question number 5. Let O be the binary operation on the set Q0 of all non-zero rational numbers defined by A operation B is AB by 2, A into B by 2. So Q0 is basically non-zero rational number, all the P by Q forms with non-zero value. So the operation is given as A into B by 2, and this A and B are belonging to this Q0. So we have to find out whether it is commutative, associative, then the identity element, and then the inversion or inverse. So first we'll start with the commutative A operation B, whether it is equal to B operation A. Let us see. A operation B is A into B by 2. B operation A is B into A by 2. So what do you get? They are equal. So this is commutative. Associative A operation B operation C, whether it is equal to A operation B operation C, one at a time, one pair at a time, AOB and then BOC. So this is AB by 2 operation C, this is A BC by 2. So this is AB by 2 into C divided by 2. Here we have A into BC by 2 divided by 2. So we have a 4 in the denominator, 2. Okay. So ABC by 4. Here we have A BC by 2 by 2. That is again ABC by 4 we are getting. What does it mean? It means it is associative. This star on this Q0 is associative, right? Okay. Coming to the identity part. What is identity? In this Q0, if you take any element A and operate with that identity element should also belong to that Q0. The same element should come back. A operation E should be equal to A. Okay. Okay, see, A operation B is given by A by 2 in this question. So we can write AE by 2 equals A. This AA gets cancelled. E goes on the right hand side. E becomes 2. So E equals 2 is the identity element in Q0 with respect to this operation O. Now coming to the inverse. What do we do in inverse? We say if we have an element A and an element B coming from Q0 and the operation gives you the identity element, then B is the inverse of A is the inverse of B. A star B is AB by 2. E is also 2, which we just found out. So we have to find out B. B is the inverse. So B is, that is 4 by A. So B is 4 by A, and this is going to be the inverse of A. Question number 6. On R minus 1, that is all the real number except 1. We cannot have A or B or anything which is equal to 1. So binary operation star is defined by A star B equals A plus B minus AB. A plus B minus AB. Prove that star is commutative and associative. It is commutative and associative. So if you see the exercise 3.2, even this exercise, the question number 3rd, almost similar. So we have already talked about the commutative and associative. So we are not going to do this here again. This will just be a reiteration, but we will talk about the inverse and the identity. So let us start with the identity. How does this identity come? If A is operated with E, you should get A back. A operated with E, A should be coming back. So A plus E minus A, in place of B I am replacing by E. A plus E minus AE should be equal to A gets cancelled. E you can take common and you can get 1 minus A with E. So E 1 minus A equals 0. That means either E is equal to 0 or 1 minus A is equal to 0. So that is E equals to 0 or A is equal to 1. But as I said, A cannot be equal to 1 because the set is not having 1, R minus 1. So A cannot be 1. So E has to be 0. That is E, which is the identity element, is 0. Coming to the inverse part. In the inverse part, because identity we already got, it's equal to 0. Inverse is A star B, B star A, and then we have the E as the identity element. A star B is the inverse if you get E. So A plus B minus AB is equal to E. E is actually 0 here. So we have, this is minus, negative. What do? We take A on right hand side. So we get B minus AB equals negative A. We don't want this negative, so just replace this. AB minus B will be equal to plus A. Now take B common. A minus 1 you get equals A. B equals A by A minus 1. Okay, this is your B equals A by A minus 1 is the inverse of A in R minus 1. Because if you get A equals 1, take A equals 1, it will be A by 0 and that will not be defined. This is the inverse. Question number 7. Let R0, this denote the set of all non-zero real numbers, and let A equals R0 cross R0, R0 that is, subscript is 0. If star is a binary operation on A defined by, how is it defined? It's defined like this. A comma B operation C comma D is equal to AC, they come A and C first multiply, and second pair multiply B into D. This is what is given in the question. So we have to show this star to be commutative or associative, then identity, then the inverse. That is how we are going to go about it. So since we have this AB cross CD equals CD cross AB, that we have to find out. AB cross CD is already given. So we'll just replace it, CD cross AB. So first pair has to be multiplied, that is first value of the pair, AC and A. So AC. Then we have D and B, that is B into D. Just write B into D. Okay. So you have both as same. So A star B equals B star A, that is equal. ACBD, ACBD, that is, it is commuted. It is commuted. Now coming to associative. Associative means what? A operated by B operated by C should be equal to A operated by B operated C, and we take association. But here we will take pair A, B, C, D, E, F. We are taking E, F. And then that has to be equal to A, B, C, D, E, F, and we'll take pair one at a time. That is, in the first case we'll take A, B, C, D. In the second case we'll take C, D and E, F. So A, B, C, D will give you AC and BD. AC comma BD. And here we have star EF, EF. We have AB. What do you get here inside? CE and DF. CE and DF. Okay. So this AC into E means first value of the pair has to be multiplied. ACE, you get BDF here. On the right also you get A into CE and B into DF, BDF. What do you see here? They are equal. So they are equal, that means they are associative. This operation is associative on this set. I hope you got the idea. Let us clear it and let us come to the identity and inverse part. So identity will be what? A star E equals A. But still we don't have A here. We have a pair. So we'll write A as A comma B. But this E, that is the identity element, will take some other thing like XY. Say it's XY because it has to be an ordered pair. XY operated, and it should give you A, that is A comma B. Again A will come. So let us multiply A into X, B into Y. This is equal to A comma B. Now just equate AX with A and BY with B. So X becomes equal to 1, A gets cancelled. Y is B by B, that is again 1. So this XY, which is the identity element we are talking, is 1 comma 1. Right? When we have the identity element, now we can go for inverse. So for inverse, what do we do? See, A star B has to be equal to E. B is the inverse of A. If we get E as this result, B is inverse. So A comma B, in the place of B, let us say CD. So A comma B, C comma D, and we operate them, and what we get? E. E is what? 1 and 1. So 1 comma 1 we take. So this is AC, This is AC you get, and you get BD, and this is equal to 1 comma 1 BD. Okay, 1 1 1. So now you equate. We equate AC should be equal to 1 and BD should be equal to 1. We have to equate. So AC equal to 1, BD equal to 1, and since CD is our inverse, we need to find out CD from here. So C will be what? 1 by A, and then we have this D we have to find out. So D will be equal to 1 by B. So 1 by A and 1 by B, this is the inverse of AB for all AB belongs to that set A. Question number 8. This is important. Why? Because this is a NCERT question. Those who are from NCERT, you are also doing the NCERT in R.D. Sharma. R.D. Sharma has NCERT inside it. Okay. Let star be the binary operation on n defined by A star B equals HCF of A comma B. Does there exist identity for this binary operation on n? So we need to find out whether this identity element exists or not. This is the question. But just to revise or recall, we know HCF and this LCM. The highest common factor is found by finding all common factor of two numbers and selecting the largest number. For example, 8 and 12. Let us find out all the common factors of two numbers. 8 is what? 8 is, let us find the factor first. 1, then 2, then 4, then 8, like this. We have all of these as the factor of 8. 12, we have 1 and 2 and 3 and 4 and 6 and 12. All are these the factor of 12. And now take the common of these two. So you have common 2 and 4. 2 and 4 are common. In these common, you have to find out the highest one. Highest one is 4. The highest value which can divide both of them. But it has to be common to both of them. So this is the highest common factor. Even see, if LCM is also there, so if you multiply HCF with LCM, you will get the multiplication of these two numbers. This is also an identity. Okay, coming back to the question, let E be the identity element. And we know this identity element will only come when we have A operated with that identity element and we get the A back. So A star E, you get this A back. So what do you get? A star is the HCF of A comma A. And you should get always A back. And that is not true at all. You take any value. You take say 2 comma 1 or 5 comma 1 or 13 comma 1 or 13 comma 0. Whichever you take. You won't get A back always. You can see very well. So we cannot find E that satisfies this condition. Therefore, we can safely say the identity element with respect to star does not exist in n. That is the logic. If you want, see 1 and 0 normally you get as E. Even if you put 1 and 0 with any of the example taking from the natural number as A, you won't get the result. This is very true. So this 8th question, NCERT question, we will say this E does not exist. There is one more which is the extra question. If you have in your edition, just have a look. So thank you so much. This is all about this exercise. Take care.